So this is our executive summary. This project aims to enhance isochrysis production and increase DHA content through optimizing growth conditions and nutrient supplementation. By investigating light intensity, temperature and nitrate levels, the research seeks to maximize isochrysis biomass and DHA content. The market value is 1.6 million ringgit with a 4-month duration in a standard laboratory setting. Our goals include improving cultivation practices for economic feasibility in aquaculture production and advancing microalgae cultivation. So we have three problem statements, which is first, determining the optimal light intensity for maximizing isochrysis biomass productivity while maintaining cellular health. And the second is understanding how different concentrations of nitrate and phosphate affect the DHA synthesis and isochrysis. And then the last one is identifying the best combination of both light intensity, nitrate, and phosphate to maximize both biomass productivity and DHA. Our research questions are: how does light intensity affect the biomass productivity and DHA content in isochrysis cultures? And what is the impact of phosphate and nitrate on the growth and DHA accumulation in isochrysis? And the last one, what combination of light intensity, phosphate, and nitrate concentration yields the highest DHA content and biomass productivity in isochrysis? The objectives for our mini project is that we want to determine the optimal light intensity for maximizing isochrysis biomass, identify the growth rates of isochrysis after cultivating it with phosphates and nitrates. And then the last one, we want to investigate the impact of light intensity and nitrate supplementation on isochrysis biomass productivity and DHA content.
This is our literature review for to know what kind the conditional of isochrysis can leave. So first is high in essential fatty acids, especially DHA, making it valuable for nutrition. And then the light regress like for photosynthesis. Optimal light intensity varies, but generally range from 50 to 200 micromole photons meter cubic per second. And then for the temperature, grows best between 20 until 25 Celsius, with some strains tolerating likely higher or lower temperatures. And then salinity thrives in a salinity range of 20 until 35 ppt or parts per thousand. And then for the pH, optimal pH range is between 7.5 and 8.5. And then for the nutrition, isochrysis requires macronutrients like nitrate, phosphate, and then silicate, and micronutrients like iron, manganese, zinc, copper, and vitamins. So for the centrifugation, effective for high density cultures but energy intensive. So these our materials and methods. For the isochrysis was obtained from the Algae laboratory of the UPM Science Faculty, and then stock culture were maintained in V/2 medium at 20 degrees Celsius on 12 light and 12-hour dark cycle. So for the isochrysis will be mostly carried out in indoor room 1 by providing increased light intensity, phosphate and nitrate, which will increase biomass productivity and DHA content, with the highest increase in DHA occurring at medium nitrate concentration. Research activity, we have 3 effects for our research. The first is effect of increasing light intensity to a certain level will increase isochrysis biomass productivity. So for this effect, we have 3 intensity. The first is the maximum of intensity 500 mole per meter square per second, and then the optimum intensity of 400 mole per meter square per second, and then the last one, the minimum intensity of 200 mole per meter square per second. So from the 3 intensity, what's the best we use? We use the optimum intensity of 400 mole per micro square per second, and for to have the isochrysis for the maximum biomass, like the 1.25 gram per liter and lipid content 71.1 mass percent. So the second is effect of added nitrate and phosphate on maximum growth and the HA content of isochrysis. So we have two, the phosphate and the and then the nitrate. So isochrysis culture with 300.0 milligram per liter nitrate yield DHA 8.9 times higher compared to the maximum biomass concentration of 4.80 gram per liter. So the next is the three effect from our research activity is the effect of the providing moderate concentration of the nitrate will increase biomass productivity and the highest DHA content. So we have three concentration, the maximum concentration with 300.0 milligram per liter nitrate, and then optimum nitrate concentration and the minimum nitrate concentration. So what the best the concentration nitrate we use the optimum nitrate concentration. Why? So the isochrysis attained maximum cellular density at the 8 millimeter nitrate. So this is the best the effect for our use for cultivation the isochrysis. Next is the flow chart of our experiment to cultivation isochrysis. The first, we to prepare the environment used to grow isochrysis. Next is sterilize glassware and equipment, and then prepare the culture media, and then we must to inoculate isochrysis culture into the flask, and then set up the light and nutrient level for 3 flasks. For the light and nutrient, I have to explain from the slide, and then the calibrate water bath to maintain the optimal temperature, and then we must to monitor initial growth parameters of culture, and then let it be for 5 until 7 days, and then we measure biomass production using optical density and dry weight measurement. And then we measure biomass again production using optical density and dry weight measurement. So why we do this twice? Because we have the 2 cycle for the cultivation isochrysis, and then the perform lipid extraction on samples and compile and analyze collected the data, and then interpret result and impact of variables, and the last one is the make the report. This is our schematic of laboratory or field culture isochrysis. We made this figure or design make from the application name is West Lab. So this design according to the previously determined size. So on the design we make the shelf, and then sink, and then we have the bench in the indoor room 1. And for the schematic of lab or field culture isochrysis, we make the design indoor room 1. We make the 2D and the 3D. So you can see in this slide, the right is the indoor room 1 3D from top, and then the left is indoor room 1 2D. Then this is the design or figure of the indoor room 1 3D from this is the design or figure indoor room 1 3D from the right, and this is the indoor room 3D from diagonal view. So we make the design from the top view, and then left view, right view, and diagonal view. So in this room, indoor room 1, we make the cultivation isochrysis.
So for the harvesting process, Isochrysis reached maximum productivity and biomass output in 8 to 10 days of cultivation. The full cultivation cycle lasts approximately 14 days. The stationary phase begins around day 8 to 10, followed by a declining phase until day 14. It is recommended to partially harvest Isochrysis at days 8 to 10, as these are the ideal periods to collect the culture. In the first experiment, the centrifuge was run for 30 minutes with a rotation speed of 2,800 rpm and a product flow of 1,500 liters per hour. In these 30 minutes, around 1 kilogram of paste was produced with a dry weight of 15.4%. The remaining fresh culture was centrifuged with default settings, rotation speeds 4,200 rpm and product flow 1,800 liters per hour, resulting in 6.1 kilogram paste with a dry weight of 14.2%.
Our company's name is Ecotide Fish Food, and our jargon is natural marine diet. So what is the Ecotide Fish Food? Ecotide Fish Food from the Isochrysis for the fish food and larvae fish food, a premium dietary choices for your aquatic companions, specially formulated with high-quality Isochrysis algae, renowned for its nutrient-rich composition. Our product ensure a balanced and natural marine diet essential for the health and vitality of fish. So this is, you can see the logo our company. This is packaging of our product. So you can see the front view and the back view of our packaging. In our packaging, we use the ziplock. Why we use the ziplock? Because efficient and safety for our product. And that's so efficient and safety for our customer. Our product, we have make the label of product. So in the label we make the nutrition, ingredients, and the expired for this food. At the Ecotide, we prioritize sustainability and quality, carefully selecting ingredients to deliver a wholesome diet that mirrors the natural aquatic environment. So with our commitment to excellence in aquatic nutrition, Isochrysis Fish Food provides your feed with the essential nutrition they need, promoting their well-being and longevity. Discover the natural goodness of our Isochrysis algae fish food, meticulously crafted to enhance the health and vibrancy of your aquatic companions. So for this one packaging, the price we sell is in the 80 grams or 2.82 ounce, equal to 40 ringgit. Our data analysis, the data analysis, we involve the use of statistical software to perform techniques such as an ANOVA, regression analysis, and correlation analysis to identify significant relationship and difference between the experimental treatments. The findings will be used to develop efficient cultivation protocol for Isochrysis that can consistently yield high biomass and DHA content, with potential application in aquaculture, nutraceuticals, and then the biofuels.
The research timeline, where the chemical preparation and lab setup was took about 1 month. That was start on 19 March until 18 April. And then the acclimatization of culture starting from 19 April to 4th May. Field culture setup cycle 1 start from 5th May until 19 May, and the harvesting started 1 week after, and the post-harvest for the packaging. And then The cycle 2 was start again, starting from 1st June until 15th June. That took about 2 weeks, and then the harvesting and the post-harvesting of the packaging, that was on 24th June. The milestones: acclimatization of algae in lab flasks start on 19th April. The cumulative project completion percentage is 10%, and the field experiment cycle 1, that took about 30%, field experiment cycle 2 15%, harvesting of algae make it to 75% of completion project, and the post-harvesting process at the 24th June until 28th June. Here is the Gantt chart of research, where the acclimatization of algae in lab flasks took part in the March, and the field experiment cycle 1 and 2 took part in April and May, and the harvesting of algae that took part in the month June, and the post-harvesting process.
So this is the table of results of what we get from our project. Table 1 shows cell count and spectral photometer reading throughout cycle. So on day 0, we get 900 cell count, and the spectral photometer reading is 0.007. And then on second day, we don't take any cell count, which is why we only check on the spectral photometer reading for our isochrysis liquid, and then on day 7 we take the cell count, which is 1333, and then the spectral photometry is 0.06, which means that there is a growing of isochrysis in our project as the day goes by. So we have the second table for this result, which is table 2, shows number of cell and the cell density of isochrysis in the second grafted throughout 7 days. So on day 0, we saw 27 of cells under the microscope, and the cell density is 900. And then on day 7, we have 40 cells, and then the cell density is 1333, which means that there is a growing isochrysis in our class. This is our graph, which shows the spectrophotometer reading versus days. And as we see in the graph, the spectrophotometer reading increases as the day goes by, which means that there is a detection of isochrysis in our project. As this goes by, it is growing. So this is our second graph. Like I said, in the table 1, we don't have any card or data on the second day, which is why it's on the second day for the cell count. So this is our cell count. If we remove the second piece, actually we have a line of our cell counts. So this is the result. For the last graph, this is our spectral activity versus cell count graph. So as you can see in the graph, we have increasing numbers of spectral activity as the cells count increases as well. So it means that the spectral photometer detects the isochrysis in the circuit rafter and also under the microscope.
Hello and hi everyone. So today I'm going to present about the budget for Isochrysis cultivation project. So first, as you can see in the table, there's a salary for lab technician, which is we pay 2,500 per month. So we time it 12 months, and we get. So here's the second table, which is a table for materials and supplies that we use during the project, which is for chemicals and also the glassware. So for a chemical, you need phosphate, nitrate, natural seawater, trace metals, buffering agent, vitamin, silicate, and also ethanol.
And for the glassware, mostly we need pipette tips, gloves, aluminium foil, and also the cotton. So there is all the price list that we have surveyed.
So next, for the professional services and consultancy, in the table as you can see, it is two, which is cryoprotectants and plastic bag service. For cryoprotectants, mostly it requires 280 ringgit per hour, and for plastic pipe, it is 100 ringgit per service. And mostly for cryoprotectant, we mostly need 2 hours per service, and in total 5 times per year, so we get 8,400. And for plastic pipe service, 5 times per year, so we have 500 in total.
And the last one is the accessories and the equipment that we need for this project. It's quite much for the equipment, such as electronic balance, pipettes, petri dish, spirit lamp, inoculating loop, printer, salinity meter, pH meter, LED light, photo period control, conical flask, and also a pump, diffuser, thermostatic control, plastic container autoclave, freezer, centrifuge, spectrophotometer, avoidance C 100 dynamic stapler machine, microscope, orbital shaker, and the last but not least is dry freezer. So when I'm doing a calculation, so I get in total all of these cost around 458,442. So here is the return of investment for our project. So per year we managed to sell 20,000 unit. So our selling price is 40 ringgit per unit, and to get our total cost, the initial investment is 458,442 ringgit, and we plus with our operational cost, which is 30,000, and we get 488,442 ringgit. And for the net profit, our total revenue is 800,000, and our total cost is 488,442 ringgit, and our net profit is 311,558 ringgit. So our total ROI, net profit time divide by total investment time 100%, and we get our return of investment is 68%.
So what can we relate from the counting algal cell density in our daily routine life? That it can help assess eutrophication levels, indicating nutrient pollution that can lead to harmful algal blooms, and serve as an indicator of environmental health, signaling changes in water chemistry and pollution levels. Accurate algal cells counts are crucial for optimizing biofuel production, ensuring consistent quality in nutraceuticals and pharmaceuticals, and also monitoring algal densities is vital for feed optimization and preventing harmful algal blooms that can affect cultured species. Based on the data obtained in the tables and the graph above, there is a clear increase in both cell count and cell density of Isochrysis over the 7 days period that indicates successful growth of the culture. The spectrophotometer readings shows a corresponding increase in absorbance, which aligns with the increase in cell count and density. The increase in cell count and density and the spectrometer readings shows that the Isochrysis of the condition were favorable and supported healthy growth for the 7 days. So the future direction of this project we need to increase annual sales volume to exceed 50,000 units to maintain RM40 per unit pricing. We also need to expand market reach by entering new geographic regions and targeting additional customer segments within the aquaculture industry. Diversify product offerings to include new formulations and specialized nutrition solutions tailored to specific aquaculture needs. Enhance operational efficiency through technological integration and process optimization to support scalability. Besides, we also need to implement sustainable practices across production, such as in packaging and distribution processes to reduce environmental impact. strengthen brand positioning as a leader in aquaculture, nutrition, emphasizing quality, innovation, and customer satisfaction, foster strategic partnerships with suppliers, distributors, and industry stakeholders to support mutual growth and market expansion. So that's all from us. Thank you.